Hello, welcome back to another Unity tutorial. Today we're going to be looking at the flow of C# within Unity. So we'll be looking at if statements, loops, and enums for our game. However, first we're going to be looking at the task that was set from last episode, which resulted in this in the console. Hello, Matty the coding helper. You have created 3 tutorials, and now 4. So the script for this short message is as follows. We have a player name, which was Matty the coding helper, which was a string. We had an int, which was amount of tutorials made, which I edited to 3 in the inspector, and a simple debug.log saying hello, the variable player name. You have created the int variable amount of tutorials made, tutorials. So with that said and done, we're going to delete the assignment and we're going to be looking at if statements. So this is known as a conditional statement. It will essentially compare if something is true or false. If it is true, it will run it, or the code within it. If it is false, it will skip over it. So we'll do another start. We can now do, it's represented by the word if and 2 normal brackets, opening and closing. Inside these brackets is where we put our condition. So if our health is less than or equal to, this is what these are symbolizing. So it takes 2 comparators, I guess. So 2 things that we're going to be using to compare. This is if it is exactly equal to. So 2 equal symbols. We also have if it is less than or equal to. So you may remember the crocodile symbols from maths. This essentially shows what do we think is more than or less than, and that is dictated based upon the way it is facing. So I'll make a comment for this. We know that 1 is less than 2, and that 4 is greater than 3. And as I said with this one, we are detecting whether it is health is less than or equaling 0. We do this in case there is later down the line a mistake on where we reduce the amount of health. If it somehow became a negative number, then it could obviously be less than 0. So we need to cover the base for if that event ever occurs, then we know that this function will still hold up. So then we can do another debug log. The player ran out of health. So the logic of this is simply stating if our int health is less than or equal to 0, print out this message. Otherwise, nothing else happens currently. We could then just do else, and yeah, do what it suggests. Debug.log, the player is still alive. So, this is an if and else statement. What this is saying is if, etc., else do this. So if this is false, then we'll do this. If this is true, we'll do this, and then ignore this. Else has to come after an if statement. You can't have an else before. You're also able to do an else if, but again, this will require a condition. Else doesn't, as it's one or the other. It's a sort of catch-all. So we can say else if health is less than or equal to 50. Debug.log, the player is injured. So, following the logic of this, if the player has less than or equal to 0 health, they've run out of health. Else, so following the logic of this, we can also do another else, the player is still hidden. So, if is detected is true, so if the player is detected, then they'll be prompted as detected by an enemy. Otherwise, so if is detected is false, so the player is not detected, they'll still be hidden, which is what we'll get here. We will now be looking at a thing called Boolean or Boolean logic. So, as we have done with up here, we have a few other tools that we have access to. So we'll do is detected. If we want to say if, well, I'll do this, if detected and if health is less than 50. Rather than having them nested, which is an if statement in an if statement in an if statement, etc., etc., we can simply just ask, is detected and, which is the and symbol twice, because remember we use two conditional characters, and health is less than or equal to 50. And you'll see that we no longer have the red squiggly line that was just present. But this now runs if the player is detected and they are on some low health. However, what if we want what if we want something where one thing or another happens? So we have and. So we have and. Now we want to find an or. So whether one of two things is true. So we'll say is detected or an or is symbolized by this icon here. Less than 50. I truthfully don't know the name of this symbol. However, on a standard UK keyboard, if you press Shift and the backslash, that's next to the Z key, you should be able to get this symbol. So this is a conditional statement for if the player is detected or they are on lower health. For this we can just say debug.log. There we go. That player is either injured or has been detected. So I guess we can have a run and see what these do. Alrighty. Going to have it start and we'll see what statements pop up. Player is alive and the player is hidden. That is correct. The player is still alive, the player has been detected, and they are either injured or have been detected. We'll drop this down to 40. The player is injured, the player has been detected by an enemy, the player is injured and has been detected, and the player is either injured or has been detected. So you can see how these affect the different outcomes based on the settings we've provided. Feel free to play around with those, get used to conditional statements and try to understand their logic. We're next going to look at the different loops that we can do. So for example, there is a thing called a for loop, which is syntaxed in a very specific pattern, but we'll go through and understand what it means. So, the syntax for a for loop is as follows. We create an integer. We just give it a temporary variable called I. We set that to equal 0. We then have a check for if I is less than 5. We then increase I by 1. This is a shorthand version of writing what we had done before. So I'll just do int temp int equals 1. 1 equals 1 plus, sorry, temp int equals temp int plus 1. Temp int is now 2, as we can see with our little code, but we can also do temp int plus plus colon. This is a shorthand version of this line. They do the same thing. Temp int plus plus is the same as increasing temp int by 1. Likewise with temp int minus minus is the same as doing temp int minus 1. So what we're doing is we create a temporary int variable, set it to 0 or whatever sum we wish. 0 tends to be a default. We then can have a length. This this number dictates what how many times we iterate through. Do 4, and then we increase. So what will happen is when this bit of code runs, we'll print loop and the loop that we are on. So I'm going to remove those for a bit, and we can see how this runs. So if I go ahead and press play, you can see that we have 0, 1, 2, 3. So what we need to understand is we set this to less than 4. So if you're confused as to why 4 didn't appear, that's because it would have to be less than or equal to 4 to print from 0, 1, 2, 3, 4. However, we only want it to run 4 times, which is why it only appears 4 times. We're also able to loop through specific components and scripts and objects. So what I can do is do public game object. Remember, game objects are the things that appear in our hierarchy that have a physical space within our game, or physical representation within our game. So I'll make an array, which is a group of whatever we request, essentially. So those are represented by 2 square brackets after the type that we put. and we'll say guards. This also does work for any data type. So int will make an array, call it numbers. And I think if we head over back to Unity, yes, we can now see that we have them popped up. So if I look at numbers, you can see that we can just have a group of different numbers that we can store, and they are saved within this variable, an array of ints. Likewise with guards, we set them to game objects, so it's expecting game objects. So for example, we can throw in a player. I know they're not technically a guard, but they're a game object, which is what it's expecting. But we'll zero these out for the meantime. And as an example, what we can do is, for each, we will set it as game object guard in guards. So the syntax for this one is, for each, then we need to create a temporary variable. So like we would normally create a variable up here. Temporary means that it's only created within this area. Create a guard that we'll search for in guards. And we'll say debug.log guard.name. So what this will do is, for every game object in guards, it will take the first one, temporarily assign it to guard, and then print the name of that game object. This will be handy for later down the line when we might want to all edit things in bulk. It'll be good to have them all contained within an array or a list, which we may look at later, so that we can do, for example, guard.getComponent. So this is getting a script that is expected on this game object. We could do guard. We don't have one currently, so it's going to throw some errors. But we could then do set alerted. So if we wanted to get all of our guards to be on alert, this function theoretically would do that. And lastly for today, I'd like to have a look or show you guys things called enums. Enums basically allow us to set up different states that we would like within our game. So we could say alert state. And it's similar to writing a function, except each line will say stealth, suspicious, and alerted. So each different value that we have here, you can see it's equal to 0 if I hover over it, or 1 or 2. We can use these states to control some logic within our game, be more readable in terms of what our code can look like. So I can do the public, now that I've created it, alert state, and we'll just call it current alert state. And in start, we can do an if statement. So for example, if current alert state is equal to alert state, which is essentially the group that we're trying to get the variable from, dot alerted debug.log, the guards have been alerted. Enums are very valuable as a resource or a tool that we can use, because not only can it be done for something like alert state, but it can also be done for things like the current game state. So whether we're in a certain part of the game where there aren't any guards but it's in the tutorial state, can be really useful. You can also see with an enum how it's represented in our inspector. So we have our current alert state, and from the drop down we can pick all the different versions or names that we had put within the actual enum. And with that, I think I'm going to keep this tutorial, I think, relatively short once it's edited down, purely because I don't want this episode to be entirely overwhelming, as it's a lot of new things to people that they might not have encountered before. But with that said and done, I'm going to show the task for this week. So, when I press play, we're going to be spammed in our console. You can see that the current state is alerted. However, if I unclick is detected, you can see that we're currently in stealth. And if I click it again, you can see it goes back to alerted. And I think with how full on this episode has been, I'm going to give you a couple of hints for this week's challenge. So firstly, I'd like you to try and replicate this. And as you can see that every time our game updates, we get the current debug.log in our console of the current alert state, which at heart is just a new variable that we've put in, the same as if it were a Boolean. We're comparing if is detected is true or false. So a conditional statement might be beneficial, and then setting the current alert state based on that condition. I hope that's an okay hint. So I wish you the best of luck. To wrap up for the episode, if statements let us make decisions within our code, loops let us repeat actions within our code, and enums let us describe states clearly. Next episode, we'll be looking at a few more things in terms of the base of Unity. So we'll be looking at Unity's script lifecycle. We'll look at a new function called awake, along with start and update again. And we'll go into more in depth on the different types of update that we can use. Thank you all so much for watching. I appreciate you being here. Please feel free to, if you enjoy the series and to try and help keep it going, a like, a subscription, and check out the Discord in the description below. And I'll see you next time.